we talked about pulse amplitude modulation or amplitude shift keying, right? So what we do, what we did was that or right, this was the waveform that we considered, and we built upon this. Now let us move on to another form of modulation that is known as phase modulation. So phase modulation, we have SMT, or we know what phase modulation is. Real part of GT e to the power j 2 pi small m minus 1 divided by capital M j 2 pi FCT, where so what we are doing here is we are changing the initial phase of the transmitted signal, and that is chosen as one out of we agree on this, or this seems right, guys? Does this seem right?
Yes, sir.
Any feedback will be welcome.
Yes, sir.
Yes, so we are changing the initial phase based on such that it is one of the M phases, and M can be, or M equals 2 to the power k, where we group bits into chunks of k, or one symbol is equal to k bits. Now SMT equals real part of GT e to power j 2 pi m minus 1 divided by capital M e power j 2 pi FCT equals GT cos 2 pi FCT plus 2 pi small m minus 1 divided by capital M. This guy, right? Equals GT cos 2 pi FCT or rather I should write it this way. GT cos 2 pi m small m minus 1 cos 2 pi fct minus gt sine 2 pi by m small m minus 1 sine 2 pi fct. Oh, sorry about this. Theta m equals m minus or 2 pi by m minus 1. Right? Agreed? Now, for all m, Es or Em equals this is obvious. Is this obvious? Shubhashish?
Sir,
Yeah.
yeah, it's obvious.
Yes. From this is obvious. And therefore, average energy per bit, EB average. This, if I didn't define it earlier, yeah, average energy per
Sir,
bit.
EM is equal to half EG because the average power of cos is 1 by 2.
Yes,
Okay.
or the power of cos 2 pi fct is half, not the average power.
Yeah, sorry.
Yeah,
Yeah.
so average energy per bit is Eg divided by 2 log to the base 2 capital M, right? Now, but this is not the end of story. Interesting. The interesting part is this. Let phi ct equals 2 upon Eg cos 2 pi fct phi st equal right. Then SMT equals root over Eg by 2 cos theta m minus root over eg by 2, sorry, root over eg by 2 cos theta m phi ct minus root over ag by 2 sin theta m. Right?
Yes, sir.
Yes, sir.
Fine. And phi ct and phi st are orthonormal. These are orthonormal. You can check it.
Yes.
Cos over one symbol period, or even over n symbol periods, these will be orthonormal. So Sm, the signal vector, becomes Eg by 2 cos theta m, Eg by 2 sin theta m. Fine. This is the signal vector for m equal to 2. Sm equals Eg by 2 0 and right.
Yes, sir.
For
Sir, for
yeah,
m is equal to 2, eg under root eg by 2 comma 0 is for which bit?
this can be allocated any bit.
Oh, okay. But they are for two different bits. That is what is.
Yeah, there are two possible symbols.
Okay.
So, or this is m equal to 2 or k equal to 1. So there is, it can represent, so one bit can take two values. So this symbol can take two values. So this is for, or you can say k equal to 1. This is k equal to 2. 1 0 0 1. Fine. So the constellation phi ct.
Sir,
Yeah.
sir, can you explain like how this SM got these values? Like not that M equal to 2, K equal to 1 step there.
Yeah. So here theta m equals m minus 1 by 2 or into 2 pi. So, sorry. Fine. Equal to for in this case. So theta 1 equals 0. Theta 2 equals pi. I substitute those and I get these.
Yes.
Fine.
Okay.
So here theta m equals m minus 1 by 4 into 2 pi equals m minus 1 pi by 2. So theta 1 equals 0. Theta 2 equals pi by 2. Pi theta 4.
Excuse me, sir.
Yep.
So that phi c and phi s we are taking to be root of 2 by Eg, right? Like, is it any reason we are taking it, or like we are assuming it, like we are taking that value and we are proceeding with the further?
Sorry, we are taking what?
For phi c and phi s is there. So function phi c of t and phi s of t.
Yes.
And
So
there we
see,
are.
this root over Eg by 2 is just to make that phi c and phi s. These should be unit or these should have unit power.
Okay.
In order for these to be orthonormal, they should have unit power, right?
Yeah.
And these are simply the normalizing powers. So we calculated that this
Like,
thing.
if we consider
Sorry,
phi c alone,
sorry.
it will
There
have
should
power
be
of.
GT. There should be a GT here. My bad.
Yeah, that's okay.
Yeah, my bad. So I earlier above I had considered GT, but in this step I missed GT. Yeah, that is on me. Now fine.
Yeah, so okay. So is it that SM should have a unit power? Like, are we trying to get SM to have a unit power?
SM won't have a unit power. SM would have power EG by
EG by 2. EG by 2.
yeah.
Okay. Fine.
SM will have power EG by 2. These so basis should have unit power. We are expressing it as a basis.
Yeah. Okay. Okay. Fine, sir.
Fine.
Yeah.
So this and SM EG by 2 times this. So theta 1, theta 2, theta 3, theta 4, and SM takes these values. So yeah, for 2 minus and D min or minimum distance equals or minimum distance between 2 points equals right.
Yes, sir.
Yes. So here in this case, me use crosses everywhere. Fine.
Okay, sir.
So now based on this, right? Minimum
Yes.
distance between two points is
Yeah.
root over EG.
Yes, sir.
Fine. So now similarly, What's wrong? This is working. Why isn't scroll working? Okay, so now it's working. Just a second. Do write this in the course feedback that OneNote crashed too often. Yeah. Anyway, let's make do with what we have. For
Sir,
yeah,
you said that D minimum will be useful, right?
yes, it will be useful.
Will it
Patience.
come? Okay.
It will come. So, like, what should I say? They started showing you White Walkers from the first episode, I believe. And the White Walkers came were useful when? Which season? Have that much patience. It'll be useful before the 8th season. I promise you. And yeah, for m equal to 8, k equal to 3, theta m equals m minus 1 times small m minus 1 times pi by 4. And this is a constellation, kind of a circle with EG. Fine. And in general, for MPSK, so for m equal to 2, 2PSK is called BPSK or binary phase shift keying. Q 4PSK is called QPSK. PSK, quaternary phase shift keying, and after that we simply call it MPSK, where M is the number of symbols. In general, for MPSK, Mn equals Fine.
So what is DMN exactly?
Okay, so distance between SM and SM. That I thought was clear by the expression.
So SM is what we were representing. Like SM is another this thing, another.
Yes, SM is one symbol.
Completely.
So or distance between 2 points in the constellation.
Okay.
Okay.
Okay. Sir.
So this should be D-min. This should be D-min because this is for m minus n equal to 1. 1. Or this is for nearest neighbors. Fine.
Yes, sir.
Yeah, excellent. So another way of looking at this is, or a simpler way of looking at this is, you take points here and you take point here. Fine. So fine. So let's assume that my drawing is right and this is so this base of this triangle is approximately equal to, or this perpendicular, whatever you want to call it, approximately equal to,
Excuse me, sir.
yes.
I think root of 2 EG should be there, right?
Okay, so let's do this the long way. See,
Because 1 minus cos theta is equal to 2 sin square theta, I guess.
yes, but there is always, okay, yeah, that is 2 sine square theta. Yeah, there should be a 2. There should be a 2, you are right. There should be a 2. So let's do this again. Let's do this again. So just a second, let me yeah, there should be a 2. Now the eraser is not disappearing. Maybe Microsoft Whiteboard has improved. Do you have any idea? Because when we started, Whiteboard was buggy. But now it seems that OneNote has become buggier. Anyone has used Whiteboard recently?
Yes, sir. Whiteboard is. I mean, the whiteboard app is fine. Using it in Teams is not. Is still buggy. If you
Okay,
have the whiteboard app. Uh,
let me try the whiteboard app. Then we can figure out another way of sharing these notes, because OneNote is becoming too buggy for. Why would someone search Microsoft Whiteboard? Search White Hat Junior from my laptop. Anyway. This hasn't gone, so let's close OneNote. Okay, so the bottom line is,
so you can also use. I mean, you can use Jamboard and then share the link so that we can later on see the notes and share the view
yes,
only link.
yes, that I can see. Word is also an option. Word or Power. So Sudarshan, I believe, uses PowerPoint,
Yes, sir. So then
but
uses PowerPoint.
yeah, but PowerPoint. The problem is that PowerPoint is not continuous,
Oh, yes, sir.
because you will have to change the slide, and that is major irritant. So अलग ही level का game चल रहा है इनका. Let me try OneNote once more. Whiteboard crashed automatically. We'll have to relaunch OneNote, and next time possibly we'll start off in Word. If that doesn't work, then I'll try using Jam, because Jamboard, one problem is I'll have to launch it through via Chrome or via some browser. I don't want to have a browser open, because browsers anyway eat away resources. Wow. So all those who think that when I bought this laptop, I shouldn't have been stingy and should have gone for a Core i5 version, raise your hands. Yeah. Yeah, sorry, I was stingy 4 years back. I bought
Sir,
this four
what's
years
the
back.
RAM on?
12
What's the
GB,
RAM on this? 12
12
GB.
gigabytes. Yeah, 12 GB. It initially came with 8 GB, and then I got it boosted to 12 GB. So this time when I go home, I'm planning to get an SSD.
Okay, sir.
Maybe
Sir, I
that will
have.
help.
So you can also use one. I mean, your desktop works fine.
Hmm.
So you can buy a Wacom tablet.
See,
Costs
Wacom
around
tablet,
50
the biggest issue with Wacom tablets is that I'm writing somewhere and I am looking at it somewhere else.
So that calibration, I mean, you get accustomed to it in a day or two.
Yeah, that I'll have to possibly. If it continues like this, possibly yes, Wacom tablets. But this is the reason I bought this laptop, that I want to write on it, and it's terribly malfunctioning on that front. But yes, I look at Wacom tablets. Possibly. Ah. Yes, so. What is even happening? So, yeah. Let us do it this way. Ah, it's alive. So. Just give me another minute. Yeah, now it's fine. So anyway, we stopped here. So assume that there's a point at so we can always say that there's a point at theta m equals 0, and there's another point. Since all of these are symmetric, so there's a theta. There's another point at theta m equals 2 pi by m, right? There's another point at theta m equals 2 pi by m. Agreed?
Yes.
So since all the points are spaced equally on a circle, the distance between these points will be same agreed. Kirti, agree? You agree with this?
So you're saying all the adjacent points will be having the same distance, equally spaced. That's it, right?
Yes, yes, yes.
Yes.
Fine. So let's complete this triangle. Draw a line joining these 2 points. Fine. So now if I do this, I drop a perpendicular from the center, or I draw a perpendicular bisector for this line. So if I drop a perpendicular bisector, this is so for large enough M. This will be so if this is a perpendicular bisector, this line will be approximately EG.
Yes, sir.
And this, so because of that, okay, we treat this as the hypotenuse, this as the base, and this has, so I draw an angle bisector, not a bisector of this. So we treat this as the hypotenuse. This we treat as pi by 2, or this will be pi by 2, and no, yeah, this won't be pi by 2. This is a perpendicular bisector. This is a perpendicular bisector, and because of that, this line will be approximately root Eg by 2 sine pi by m, right? Half of the line joining these two.
Yeah, yes, sir.
Yeah, so the distance d min is approximately 2 root Eg sine. Make sense?
Sir, why approximately?
Yeah, we got it correctly in the before formula.
Yeah, we got correctly, we got the exact result earlier, but this is another way of looking at it without going into all that, without going into all those trigonometric properties. Or this is an intuitive explanation for the same. That was an exact explanation.
Sir,
Yeah.
sir, how did you get the perpendicular bisector length?
Perpendicular bisector length. We don't need the perpendicular bisector length. We simply need this.
So
This
then what's the
is
radius of circle?
root over Eg by 2. The radius of the circle is root over Eg by 2. This acts as the hypotenuse. This is the perpendicular. And since the hypotenuse is root over Eg, this will be root over Eg sine pi by m. Since this angle is pi by m.
Yes, sir. Yes, sir.
Fine.
Yes.
So now if we look at the m equal to 2 case, same as binary PAM, right? Or agreed?
Yes, sir.
Binary PAM we did in the last class. So the PSK is same as binary PAM, and that is a special case. But at the same time, for m equal to 4, what we see is that right, this is this is the m equal to 4 case.
Yes.
So this is the superposition of two binary PAMs over orthogonal can we say that?
So
This is
PAMs we consider as in a straight line, no, sir.
yeah.
In the,
PM is one straight line. Or
yeah.
PM is one dimensional. Now, if we superpose two binary PAMs, we get a two-dimensional signal. So
Okay, yeah.
you have a binary PM along. So this is important. You have one binary PM on the phi c axis. Have one binary PM on the Kirti. Now,
Yes, sir. Fine.
yes, fine.
Yeah.
So now, so if we superpose two general PAMs such that AMI denotes the amplitude of the real part, AMQ denotes the then we can define a signal with a complex amplitude AM equals J and this is small m everywhere. Don't get carried away by my bad handwriting. And SMT equals real part of AM oh, sorry, GT equals AMI GT cos sine right?
Okay, sir.
Fine. So this in general can be 1, 3, rather, let me put these points as phi CT. Right? So the crosses will represent the possible points. In case of 4 PAM real and 4 PAM right?
Sir, could you explain what is it exactly?
I will give it a name later, but say I'll repeat this. Let's take 2 superposing 4 PAMs as an example. So on the real axis, it can be 3. It can take 4 values on the real axis.
Yeah.
And on the imaginary axis, it can take 4 values.
Yes, sir.
So real 1 plus real 1, imaginary 1, it can take the value this 1 plus j. This is 1 plus j.
Okay.
This is another value it can take. These are the 16 values it can take.
So you're meaning like initially we are having two PAMs, and like if we superimpose in different this thing, you will get 16 possible this thing. That's is it?
Yeah,
You're saying?
you'll get 16 possible values.
Okay, sir. Yeah.
Right.
Yeah.
So here you can say that AMI takes the values from the set -3, -1, 1, 3, and AMQ also takes the values from -3, -1, 1, 3. Agreed?
Yeah.
So you can add up symbols that are, you can add up 2 signals from phase quadrature and make up a, okay, you can add up 2 signals in phase quadrature and make up a complex modulated signal, and this is known as QAM or quadrature amplitude. But the nice thing about it is that I can also, so SM equals AMI plus JAMQ, sorry, SM equals real of AMI plus JQ GT. This beast, right? There's a GT sitting in between there, right? Now the import or the modulating symbol here is the symbol. This is the modulating symbol. If I write letting RM equal root over and theta m, we can write RM equal J theta m GT J 2 pi, right?
Okay.
So this is so you can say that this can also be seen as so this is PSK, but now you can also change the radius of the circle. This now looks like PSK, but with a variable radius.
Yes, sir.
So now if I define these symbols, these are also so so say this is A, this small radius is small a, this is larger radius is B. I can get 8 symbols that are placed on a circle or that are placed on 2 different circles, and this is a valid QAM constellation. This is a valid QAM constellation from our definition of QAM. Yes, I'm taking slightly extra time because we lost around 6 minutes due to my laptop malfunction.
Excuse me, sir.
Yeah, Kirti.
So can we see about from QAM again in the next class, like from
Yeah,
the
sure.
definition of QAM?
Yes, sure. Sure. So, but this makes some sense. Or absolutely no sense at all. Hmm? Kirti?
Sir, I didn't still get exactly what QAM, so I'm not able to still get it. What
Okay.
exactly QAM is?
Okay, we'll stop at this point and what is QAM? I'll keep this as a question and we'll possibly pick up at this point tomorrow.
Thank you, sir.
Fine. So otherwise, it's okay.
Yes,
Except the laptop malfunction, which took about 6 to 7 minutes of our time. I believe things are fine now. So yeah, let us stop here then and continue tomorrow. Anyway, the battery is dead.
Thank you, sir.
Okay, bye then. Have a nice day, all of you.
thank you, sir.
Bye, sir.